Hello, my name's Ken Kerschbaumer and I'm the European Regional Development Manager for Leader based in London in the UK. And I'd like to welcome you to this exciting panel session that the Leader Group hosted with support from Arista and Bridge Technologies on SMPTE 2110, the future of live remote production.
Thank you so much to everyone for joining us today. We're here for a lively discussion with a great group of panelists. This is the seminar ST2110, the future of live remote production. My name is Kristen, and I invite you to submit your questions in the chat, and I'll share them with the panelists a little bit later. So now I will introduce our moderator, Ken Kerschbaumer of Sports Video Group.
Thanks, Kristen. Good to see everybody. So yeah, we have a great conversation and some great panelists who will have a great conversation regarding ST2110. We're not getting into any holy wars of IP formats, SDI versus IP. Our goal is to kind of ignore those things and focus in instead on ST2110 and the role that it will play, those are my questions, in the future of the industry. So I want to introduce our panelists real quick. We have Prinyar Boon. Prinyar, you are the product manager for PHABRIX and SMPTE fellow. Good to see you, Prinyar. How are you?
Very well, thank you. Hi, everyone.
I'm doing all right. Robert Welch, technical solutions lead for Arista. Robert, good to see you again.
Good morning. Good to see you, Ken.
Simen Frostad, chairman of Bridge Technologies. Simen, how are you?
I'm excellent. Thank you, Ken.
And Steve Holmes, applications engineer for Leader.
How you doing, everybody?
And last but not least, Gerard Phillips, systems engineer for Arista. Gentlemen, how are you all doing? Let's get right into it. People, again, please file in questions via chat. And then we're going to answer, we're also going to fire up some poll questions as well to get your take on certain things. So let's begin with, we want to kind of start with crawling, walking, and then running. So first third of our program will be discussing how to crawl, which obviously begins with understanding a lot of issues. Want to have each of you offer up a 1-minute primer on ST2110, what it means for your organization, and also maybe a key concept or term that people should understand. So Robert, I'm going to give you the short straw. You're up first. What does ST2110 mean to Arista, and what's a key term that you think people should understand as they begin the journey?
Yeah, thanks, Ken. And thanks for having us, and thanks everybody for joining. This is going to be fun, I think. We're going to have, this is a good group of people. As you can see, we've worked together many times. 2110 for Arista basically means that it's no packet left behind. And what we mean by that is it's the foundation, if you will. It's the wheels on the car. It's the engine that makes things go. And at Arista here, we want to make sure that things are scalable, they're predictable, that you get the analytics that you need, the streaming analytics out of the system itself, and then, like I said, a foundation. So 2110 means to us is much like the financial industry that we have a big role in, or the cloud titans, is you want to make sure that you're building something that you can rely upon, that you can go home on a Saturday or Sunday night and not have to worry about things. That you actually have a life. Go figure, right? But the interesting thing is that, and maybe not everybody understands this, not all switch manufacturers are alike. Not all switches are alike. We spend a lot of time educating people on what's the right switch, what are the right tools to use, what are the right foundations to use, so you get back to that no packet left behind.
Awesome. Gerard, from your perspective, what does ST2110 mean for you, and then also a key concept as well?
Yeah, well, I'd follow on from Robert, to be honest. It's about live production, high production values, typically high content value, high reliability and high availability, and that for us that comes down to quality of product, quality of software. The way that we approach building products is all about that kind of resilience and quality in PTP terms, in multicast scale terms, in automation and API terms to allow you to enable access to the network.
So do you have a hot button phrase they think people should understand as they begin this journey that they may overlook or not be aware of other than 2110?
Well, yeah, I mean, you can get me going on that one. We talk a lot about COTS, and I think that's probably a concept that is worth having a bit of a conversation about. I mean, for me, COTS means commercial off the shelf, and there's, I can go and buy a Netgear off the shelf, or I could go and buy an Arista or a Cisco or a other vendor, right? The difference is not that they're not off the shelf and not commercially available. It's that you're talking about an enterprise grade piece of kit rather than a desk grade piece of kit. And surprise, surprise, if you're looking to build workflows and quality levels in your live production that the big broadcasters would be happy to pin their names against. You can't do that with some infrastructure you've purchased from the corner shop. You've got to buy enterprise grade stuff. So don't, IP should bring cost savings in certain places, but don't cut corners, I suppose. I would say don't cut corners. Yeah.
Excellent. Great. Prin, from your perspective, ST2110, what it means to you, and PHABRIX, and also a key phrase.
So one of the things I surprised a lot of our salespeople by saying is that at one level, 2110 changes nothing. This is still television. We still have video, audio, and ANC and closed captions and everything else. And what we're doing is replacing a couple of SDI and reference BNCs with an IP connectivity. It's still television under the hood. Nothing's changed there. We're still ongoing. So, so in a sense, no change. But in moving to the IP world and adopting all of that, so there's a sort of massive change under the hood. And with a test and measurement perspective, then there's a lot of detail involved in understanding all the timings you have in the SDI domain. How do you replicate those in the IP domain for all the different flows and everything else? So that's and you've basically got double the amount of work to do in the same product. That's the challenge. In terms of a key item, one thing that's very close to my heart is precision time protocol, or PTP, which is not to be scared of. It's kind of the replacement for analog reference, bisyncs or trisyncs that you have today. It's carried in band. It does work. I'm not going to go into any of the fine details of that. It's been, you can read that online. But the thing to bear in mind, and this was something a couple of people said in a seminar last week, is that in SDI and in analog ref, we're so used to working in a few nanoseconds of digital and everything else. In the IP world, certainly in 2110, we're not at CERN or the Hadron Collider. A couple of microseconds wander on this is more than adequate for what you need to do, which is quite a shock to most people. And then the other piece is that where you put your synchronizers in the system and how you time it up, that hasn't changed. It's still television. If you don't trust the clock of your outbound or inbound circuit on there, you still have a synchronizer in place. What PTP will allow you to do in the future, though, is when you move to, this is the subject, to extended LAN type applications, then that does give you the facility to remove the synchronizer, lower the latencies, if you can control the relative timing in the network very tightly. And PTP offers you different ways of doing that, and you can have time as a service in band as well. So that's kind of the start of the range of options that are available to you with this technology as you migrate from where we are now to the future that we're talking about.
Excellent. So Steve, from your perspective, from the leader perspective and from the engineering perspective, a little bit on 2110 and also another key concept that you kind of see out there.
Yeah, duplicate, most of what Prin said. The big concept is IP is just another IO. We treat it just the same as we treat SDI. It's just the tool set is different. It's still getting data from a switch to a sync device or a receiver and getting it back. Yes, PTP is how we keep everything in line, keep it all together. We need to understand that. We need to understand the data. It's just looking at different parts, and people need to understand that. And as we're going to start out here, the crawling is how you become aware of those pieces and you know what you're looking at. And as many people have said in other SMPTE meetings and whatnot, it's measure, measure, measure. You've got to monitor your network. You've got to know what's going on, because as Simen said earlier, you may be running on the backup and not realize you're on your backup, especially with 2022-7. It can hide things that you don't know that it's hiding, and you need to be able to monitor that. The other piece is, in a lot of cases, we've still got SDI being encapsulated. So it's really handy to be able to have a true hybrid solution where you can look at both SDI and the IP at the same time and see what's getting dropped or what's not there that should have been there.
Awesome. Well, speaking of Simen said, so Simen, what is SD2110? He teed it up. I had to take that one. So, as far as SD2110, what does it mean to you? And what's another key concept that you think people should understand before they begin their journey?
Well, let's say that, Stephen, here, of course, you have to measure, you have to monitor, you have to actually know what's going on. But the most important thing with 2110 is that we can finally say good riddance to SDI. And SDI has been a pain in the ass on broadcast television for much too long. And remember, in the older, I'm not saying good old, but older analog days when we have, PAL or NTSC, and it wasn't good days for TV quality, that's for sure, but it really did work, and the latency in production was near instantaneous. And people tend to forget that when we introduced SDI, it came with always 2 frames of latency whenever you patched anything up with a cord, because there were frame buffers in each end. And finally, we have 2110 that can bring us closer to that analog days back, 40 years ago, when you actually have no latency going on because the network speeds are great. And that is, for me, one of the most important parts of going 2110. In addition, you have, of course, the flexibility. There's no de-embedding, embedding. There's actually a free flow of flows of data where you actually can extract whatever you need, and you can process and insert into the stream something of value. And as processor speeds, latencies goes down on all the different kind of boxes you need in this scenario, then suddenly you can do production in a much, much better way, and of course with minimal latency, which have been the big killer for TV production for now, again, 40 years. So thank you, 2110.
I definitely second that. I think one of the things you really need to address or grasp as you move towards 2110 is that 2110 is just a transport. There's a whole stack of other layers in the cake once you move to an IP solution. But the real lesson, I think, is not to try and drag everything that you used to do in SDI into IP, because if you do that, you may as well, frankly, just build an SDI-based system. What you're trying to do is, exactly as Simon was saying, you're trying to leverage the scale, the economies, the flexibility, actually ride the technology wave, right? I mean, we've gone from, I don't know how long, when I joined Stanley Wilcox, when I first joined in 95, I started working on the first products that made, first HD products that we made. And they were boxes like cigarette packet size encapsulators and decapsulators for HD SDI. In the same sort of period of years, the Ethernet world has gone from 10 megabits a second through to 800 gigabits a second, and we're approaching technologies that will give us over a terabit per second. So if you want to ride the fast moving wave, you've got to approach it differently, because the flexibility is there, but you have to not think of it as SDI encapsulated.
And I think, sorry, Rob, I think that's key, because once you're in the IP domain, then your switch can handle a multitude of formats, be they compressed, uncompressed, proprietary, or it doesn't really matter. They're just packets going through the switch, and that's the key to giving you the business flexibility to evolve your business and move forwards in a managed way, in a way you understand, and you may end up in places you didn't expect to on the journey from when you start now, and it may be clear as day now, but 3 years time you may go, I'll take a different route, but you've got an IP router there, you're good to go. And that's
Prinyar, this is so correct, because again, it's about, we had, when we first started digital, we have, standard definition, then came HD. Well, we just swapped the boxes, the cables was pretty much the same, and then basically some not 720, but 1080. Okay, we just swapped boxes again. Then came UHD, well, we swapped boxes again. Now with IP, it's the first time we get some real significant change in the broadcast industry on how we're going to do this. So I totally agree with you.
You know, it's
So-
interesting. IP is the unifier because there's a lot of the things, the HPA Alliance going on to, this week and last week. They were talking about to the cloud and this and IP that. And it's interesting the amount of codecs that are going on and just the amount of transport. IP has opened things up and it's forced us, unfortunately, or fortunately, whatever you want to call it, fortunately, it forced us to evolve. I mean, before the whole COVID issue was, 2110 was, maybe I want to get into this. Now it's like, I have to do something with IP. I've got to do remote production. How am we going to do this?
Exactly.
And again, it's looking at it from a standards perspective too. If you go 2110, either compressed or uncompressed, you've got that unifier. You've got a standards-based solution set and the products to choose from. So I think that this is one of those things that people go, when do I start? And it's like, well, hey, it should have started way back here before the whole thing, and you'd have been better off. But jump into the deep end, and you've got a group of people here who can help you out. So
Sure.
anyway,
So
I think it's a really good time to jump into IP.
I know we have some poll questions, I believe.
Oh.
I don't see a poll function on the Zoom. So if we have that, let's fire up that first question. But also, yeah, Prin, you wanted to make a point?
Yeah, I was going to say, in by all means, jump in and get your feet wet. It is possible to start small. I mean, in fact, I wasn't meaning to do this, but I happen to be at work, and you can get a complete 2110 system into a bag this size. No, it's not a big bag, and in demo, I can kind of build that in 10 minutes and in a sales situation. So it is possible to it's all pre-canned, yes, but that is from unpacking, putting the power in, running it up, and you're good to go in that 10-minute period. So but that's a nice way of understanding how to build that. It's complete. It's got NMOS involved as well, as fits a lot of the EBU requirements as to all the characteristics of that. So it is. You don't have to. No offense to the switch manufacturers, buy some enormous piece of heavy iron here. You can start small and evolve it and learn, and also, even when you come to deploy a main system, you still need a staging system, and that staging system can be part of your proof of concept. So you're not wasting equipment by taking this route, because it's a good way to learn and learn how to configure switches and equipment and understand the new technology.
Absolutely, Prinyar. I like that a lot, and you got to start and throw yourself out on the deep end. That's obviously the only way to go forward here. And I also want to bring out one more thing, which is, again, with an IP core system, with IP as the core of your production system, well, suddenly then remote production becomes a totally different ball game, because then having these signals originated in this spare, then transcoding, signaling, and actually getting them somewhere is actually possible. And getting them somewhere over the public interweb, which is mainly IP based, I've heard rumor about. So that kind of thing becomes suddenly practical, whilst in any other kind of broadcast technology before or even now, you have to convert it to IP. So I would say the same as you, Prinyar. Throw yourself out on the deep end, do a small, interesting system, start learning about it, because this is going to be essential. It is essential right now.
Right. So, Fallon, let's fire up the poll results real quick, just for fun.
Go ahead, Ken. Sorry.
See where we stand. Drum roll. Okay, it's fairly split.
50-50. That's good.
There you go. Exactly.
That's
so
good.
for the 50 who have not been involved in, and I guess this is the key question, right? Because they're here to learn about 2110, if it's the right thing for them, how they should know. So I guess what's the key question that 52% should ask themselves first before they even, I mean, for example, is 2110, if you're building a new facility and you want to future-proof it, 2110 is what you should do. Forget about SDI and what have you. Is it that simple of an equation at this point?
It's
Absolutely.
really
Sorry, Stephen.
No, I was going to say it's really close to that, and I think that's part of what we're talking about here with the crawl. You start out crawling, you build yourself a green field, and that just ends up growing.
Right. Yeah. So let's take that to the next part two, which is a bit of the walking. And Gerard, you kind of hinted at this earlier. This is not something your whole organization has to do at one fell swoop, a big, massive, organization kind of making the move. You can experiment and take a smaller chunk. I mean, it goes back to the old HD islands, right? Back in the day, right? Not linear editing and that kind of stuff. So what are some thoughts on a simple way to begin the process of experimenting? Is it playing with multi-viewers? What are some of those safe areas that people can experiment and learn?
Yeah, sure. I mean, it's kind of what Prin's saying, actually. You could go and get a pair of switches, gives yourself some -7 resilience, and start plugging stuff in, whether that's, whatever makes sense to you, really. I mean, a pair of switches is the simplest thing you could possibly have. They can be pretty small. They can be pretty flexible. They're not, they're going to cost you some money, but then everything else is going to cost you money as well, right? It's going to cost you less than an SDI router would have cost you. But, if you start off with kind of pluggable gateways or modular gateways, or it doesn't really matter what you're starting with. One of the things I think is sometimes people are scared of jumping into new technologies, but you won't learn unless you try something. So, and this kind of plays to this idea of whether we need to try and get IT guys to become broadcast guys or broadcast guys to become IT guys, right? And I think in reality, if most people start with a broadcast guy to IT guy transition, I think that's the right way of doing it, because broadcast is a very narrow but deep vertical with a set of very specific knowledge about workflows. And so trying to transfer that to IT or IP guys, I think, is quite tricky sometimes. It's certainly not impossible. But in order to make an IP system work, you do need to have a fairly good understanding of how does IP work, how does unicast work, how does routing work, how does multicast work, and how do you make PTP work? And to be honest, you won't learn anywhere nearly as quickly as if you stick a couple of switches in and get yourself a few sources and a few destinations and have a go. So certainly it's an approach that I've seen many broadcasters take, and they build a sandbox, or they build a lab, or they build an OB truck, right? OB truck, what a brilliant place to start. Massively self-contained, small, limited, scope is not enormous, and functional. So that could become your first IP island in your SDIC. And as you say, if that grows, then you flip that over, right? As we went from SD to HD and HD to 3 gig, you could easily start with an IP island and flip that later on when you need to.
Gerard, this is exactly why you need to be, again, fluent in IP. And when we talk about IP, it's kind of a large field. So IP is not, really one kind of term. There's a lot of in-strict technologies that needs to work. You have to have address delegation, DHCP servers needs to be understood. There's a lot of in-strict services that we used to in our IT kind of based environment that needs to be in place in a broadcast production network as well. And that's where the learning curve becomes so important, because all these things are just as important as in a normal kind of IT-based network, but of course becomes doubly so in an ST2110 network, because those things has to be fundamentally in there before you can throw any additional load, like again synchronization PTP, which then, of course, is very important. But let's not forget all the other things that is important to make it work. And that's where I believe the jungle is there, because the IT people, they're not very comfortable with the broadcast specification set. But sooner or later, as I know Robert has some opinion about, they have to actually make do with it, because the IT industry is catching up very, very fast. And they also need a lot of the precision that we in broadcast have got via the 2110. So I think the merging of the IT engineer and the broadcast engineer is something that it has to happen.
I think also at a business level, you need to understand what the technology can bring you. I mean, the classic thing in a truck is that moving to fiber everywhere, getting rid of the copper saves you about 7 tons in a 26 to 30 camera outfit, and that makes a big difference in a truck. It's not so much a big difference in a studio. Certainly, above 5112 squared is the kind of finger in the air point at which the IP switch becomes very cost effective, even allowing for gateways on there, which is not a big broadcast system. But fundamentally, if you're just replacing SDI with IP, that's not going to drive your business. You have to think about how you want to be able to scale up, virtualize, run equipment as efficiently as possible, make it centrally allocated or remote access, which is we talk about remote production now, and there are many different definitions of what that means. And one of the things that IP does bring you is being able to remotely control and access equipment all over the world with Simon's point, remarkably low latencies in there, and particularly with what everyone's had to do with COVID. And a lot of the work that's been done with, certainly in the UK, Project Restart, with the football coming back, has been remote control of equipment and trucks that have been physically at the stadiums has been the first stage, along with broadcasting from home. So that has given a lot of business changes. And from that, people are now looking at, how can I then evolve that what I've got there into a topology that still gives me that overall flexibility and agility, which is simply not possible with SDI. And that's where it gets really exciting with these systems.
I think there's it's difficult to know whether, I mean, we're throwing terms around, right? Remote production, distributed production, whatever you want to call it, production. Essentially, it's production where you've got a bunch of kit on the ends of bits of Ethernet cable, on the ends of WANs and stuff like that. The other use case I've seen recently is where economics is driven. IP is given the ability for somebody to drive the economics of their business the right direction, and that's been because they found places where the operators cost less. And so if they put the monitoring tools and the operators in countries that cost less, but they're all connected to everywhere else, then their cost of production has gone down. So I think there are as many different reasons to use the flexibility of IP as there are different businesses out there. I mean, nobody's ever got the same, everyone's IP looks different, everyone's SDI look different. I think everyone's reasons for doing it are different, but fundamentally it's the flexibility of IP that brings that.
Yeah, if you talk to the truck companies, a lot of them, when they first looked at IP, it was to Prin's point, a lot less weight, but also to make it so their trucks could do any size show. They didn't have to worry about this sort of the show's too big for this truck, we have to roll out another truck. So there is definitely a business case there. I guess one question as far as is this all about Cisco certification? What's sort of the training? If you're a broadcast engineer, I know I've always heard that for years. What sort of some simple tips on coming up to speed on IP, if there are simple things to do on IT? Robert?
I'll go first. Everybody has one of these, I think, or maybe not this one. Maybe you have your own. It was a joke, sorry. But everybody has a home network, right? Learn how your home network works. You got DHCP on there, you got IP, you've got routing. Okay, if you can get that down, you are golden. You're halfway there. In fact, I posit that if you're a broadcast engineer, you're going to be a better IP engineer, network engineer, if you will, than you will coming from, and I hate to say this because I was, this is how I grew up and it's paying my bills and hopefully my 401k for forever else. I'll go to them. It's harder for the IT guys to learn broadcasting, and that's because it's just so live. It's now there's that sense of urgency on the broadcast side. And so there's just some basic things. There's a tremendous amount of training out there. If you don't know, come to one of us, and we're all open to this, is learn just IP, subnet masks, multicast, PTP. All very straightforward and stuff that we can show you and get you some hands on it. We can take you from zero to hero in a day, literally a day. And
I love this, Robert. Zero to hero. You are my favorite quote guy. This is excellent.
I don't know if you guys agree, because we've been doing this for a while, where we've been training people hands-on with IP and taking the broadcast engineer. And it's just, the first thing is got to just jump in. Now, if the CCNA thing is okay, but you learn a lot of product stuff, just jump in and learn about IP and how it works. That's how I say.
What I did is we borrowed a switch from Arista, and I started getting them running there. So, and thanks to Gerard for that. But after about a year, 18 months, the engineer said, Prin, go and learn the proper technology. So I did a SMPTE fellow, SMPTE we're running courses, so anyone out there, by all means, go and look at what SMPTE are doing. And I took the SMPTE sponsored CCNA Part 1 course, and that kind of normalized my language and thinking, and as to how those systems fit together. So that's the route I took.
Yeah.
And but I'm not an expert by any means. We have people who are steeped in this on this call. I must stress that.
So what you said, Robert, the data guys are used to sort of good enough, because in most data protocols, you drop a packet, okay, you NAC the packet, you retrans. So what? It's a fraction delay. Video, you drop a packet, that packet doesn't exist anymore. That frame is gone. So I think that's one of the things that the broadcasters already know and already have in mind that makes them much better, like you said, coming from the broadcast community into the IP community. They've already got that mindset that, you drop something, you drop one packet, it's roughly, 1080, it's a quarter of a line, and that can destroy an entire frame if you don't have things protected correctly.
I believe that's also the way of success potential for 2110. Well, to be honest, 2110 is already a success because there's a lot of real deployment. We have like NAP Australia, which has been running a complete hub-based, distributed, remote production capable network in Australia for now over 4 years on 2110. So this is not, this is pretty mature. But I believe that, again, between the broadcast engineers and the IT engineers, that it's much better, as Robert said, to come from the broadcast angle and learn IP, because we have stringent requirements that is very, let's say, IT unfriendly in a way, because we actually need it to work. And we also need to build that fundamentals, because the network is actually part of the product here, which is completely different from, the cable have never been part of the product in the kind of SDI deployment, but here it is. And that is where the knowledge base should be, and also where it should never fail, because now we have the capability with 2110 and of course -7 to be able to have redundancy, which is better than any other technology. And that is the benefits of this. But we need to understand that it can easily break. It's like, using scissors to your SDI cable. This is even more fragile if we don't design it to be anti-fragile. And that is, of course, something that people need to understand. It's a different type of animal in a certain sense.
Yes.
So Kristen, let's get to some audience questions. Never hurts. So let's go back in time to 110, because Brian was, and here's the results also. But you want to ask Brian Recke's question to our panelists?
Yes.
Let's throw it out there.
Absolutely. 2110 WAN seems an odd but potentially workable solution for the problems of multicast across a WAN or MAN. There are decades of integrated technologies moving away from multicast distribution to scale over converged IP networks. What are your thoughts on how 2110 will or should approach this challenge?
So in terms of WAN, or MAN, the Video Services Forum right now is undergoing a bunch of work there on how to best architect 2110 and P2P and control and security over wide area networks. So if you're interested in that topic, please join the Video Services Forum, the VSF, or reach out to Andy Rayner of Nevian, who's the chair of that particular group. And they're working on how, on a federated system, multiple entities can connect together over a WAN and then interchange content using the 2110, control planes, and also security protocols for that. So that work is ongoing right now. And what other people have been doing as well as experiments is a bit like the NEP system, is a very large LAN. So there's been, the NEP system's live. There's been experiments in Sweden also with the England under 21 game 3 years ago with UEFA. and also certainly audio systems for a long time, going back to the the Brazil World Cup and prior to that, where these are highly managed large area networks fundamentally, but over 1,000 kilometers long. And you can take different approaches there on how you build those systems, because that is essentially a secure system. But so that's kind of the what's happening in that world.
But I want to also come in with a short comment, and that is, of course, that you don't really need to have an overall, let's say, global or even national 2110 system. You can, have a lot of 2110 islands, and you can then, of course, do trunks between them. And that is also one of the reasons why 2110 contains the capability now in -22 to be able to handle slightly compressed media, because again, uncompressed in the 4K realm is pretty interesting in holding around, national kind of trunk lines because of its sheer scale and the bandwidth. So it makes pretty much sense to even utilize, 2022 for the time being to do trunks when you need to, and then basically use 2110 for local production, but for now. But of course, we're moving into a more homogeneous situation, but you don't need to do that right now.
Yeah, that's right. So Simen, I echo that. It's all about the workflow. Do you need to bring all that traffic back and mix it to central location, or even use something like PC or IP where you're doing remote, if you will, right? So it all depends upon what that workflow is. And if you need to do a distribution, sometimes it's just transport stream, and that's what you end up with.
Awesome.
So
okay, look at our poll
I don't
here.
think there's just one answer for it.
So our poll results here, I guess this is why we're having this call. You see that basic at best and adequate. So if anybody responded basic at best or adequate, feel free to fire in the chat why you think it's only basic at best and adequate, because I think obviously that could shape future conversations like we're having now. So Kristen, let's go to another question. Paul Breen asks a very basic question, which is a great one. I think we sort of hit on it a little bit, but fire away. It's a simple one, but very complicated, I'm sure too.
Okay. Could you provide a simple equipment list, not makes and models, but specs, for how people can get into the ST2110 world?
Oh, I love this question. It's a great question, and that is some background homework that we should all do and actually come up with basically a simplified lab. This is exactly
Simen. Now, Paul did say adding it to the end of the recording, but that's okay. We're going to do it now. So let's.
Yeah, I'm sorry, but I think it's a great thing because that will be a kind of like a easy peasy or highly subjective, of course, but a good move, because there's a lot of confusion. I saw as one of the questions, can you run a PTP Grandmaster clock on the same machine as you run your DHCP? And it's valid questions, because this is not kind of obvious in an IP system. And a lot of these things can be answered very, very fairly and simple. And I think also some of the industrial alliances tried to answer this by setting up some easy guidelines, but an equipment list for a small lab, that's a great idea.
Yeah, so I think you start off with some test and measurement gear. What do you think, leader team? Because sometimes you can do bars and tone just right with that.
Yeah, that's kind of what you need. And I would also say a switch with a boundary clock in there would be
that would be good.
Another prerequisite as well. So.
Yeah, as your sync pulse generator for PTP, you really need two of them, because you need to understand BCMA. You need to understand the failover and how it works and how to correctly configure it. And a couple switches, and you're golden.
Source destinations,
yep.
And then something to analyze it with, right?
Yep.
So it could be gateways, or they could be some playout systems. I mean, I've seen some people put 2110 on an Arduino, of all things, right? So it's compressed. So there's a lot of ways you can start. There's even little, optics that you can stick inside the switch itself if you want to start off with that. It really depends where you want to go. And then Simen, we could also start off with a multi-viewer. And I see a lot of people starting off with that.
Yeah.
I don't know if
well, look at the trucks. That's where a lot of it started, with trucks, because they were eating 3/4 of their router capacity just to feed the multi-viewer.
Yeah. No, but that's very true. And, you know, we use a lot in our office. We actually use a lot of Blackmagic equipment, which is an hyperdecks that basically play out to a lot of converters. And you know, that is basically, you know, enough for anybody to start playing around with.
Kevin's popped a little message in one of the chat things saying you could use a Raspberry Pi as an NMOS server. He's absolutely right. I've got a Raspberry Pi in my garage, which I use as a PTP GM. I mean, it's dreadful. It's software timestamp, not hardware timestamp, but it cost me $40, right? So
exactly,
you can. I think it depends what your budget is. If you're looking to do it properly, you need a couple of switches, you need some sources, some destinations, you need a decent server, which you can run a decent, you know, a couple of 10 gig NICs on, so you can do Wireshark captures or add your connectivity, run TCP dump, stuff like that. But if you wanted to start it cheaper than that, you certainly could do that.
Yeah, and I run my NMOS system off a Raspberry Pi.
Yeah.
But also Amware have made Amware made available on GitHub. It's called Easy NMOS is the kind of the marketing name for it. So it's technically it's a Docker Compose which you can download and put onto a switch, and that's a complete NMOS registry and a controller that's available there. And you can get DNS, SD, and DHCP servers as well, which will run in Docker.
And don't forget the EBU list project, which is open source and allows you to essentially capture, analyze, and verify the 2110 transport streams, PTP, stuff like that, packet analysis. It's pretty cool.
And if you also look at the J10M website as well, if you look at the, they publish the test methodologies that we use to verify all the equipment. Session description protocol or SDP files were checked with a product called SD Poker on GitHub. So you can go and look at that, and that will give you a report on there's a bunch of tools out there.
That's a great point, Ken, because if you
I love this. I love this thinking, and you know, one of the reasons that we in Bridge are in the both test and measurement and monitoring business is because that is one of the starting things. And you know, Prinyar, you said it very early in the discussion here that first you have to start with some monitoring. Because if you don't know what's going on, well, it doesn't really matter what you do. You have no idea. Either it works or it really doesn't. And that is the key component. And I would say to everybody that wants to go down the IP route, that get some monitoring analytics equipment that you're comfortable with, that can actually convey the stuff, or else you're just flying blind. Don't need to go for the top shelf stuff in the first place, but a good monitoring system is always a great place to go. Monitoring means a lot. I mean, you can't do television without a monitor, right? So already there, you already got that kind of notion. So this is just, you know, a monitor, but with a lot more capability to look into the IP packets. And if you have that, you're going to be fine.
It's the best training tool you'll ever get your hands on to learn all of it, to learn PTP, to learn IP, to learn IGMP, to learn multicast, all of it, and figure out how the flows work. I agree.
The J10M tested reports are pretty cool, actually, because they can also give you a really good pointer as to the if you're completely new to it, they'll give you pointers as to which pieces of equipment, which vendors have been through the process of verifying their interoperability. So that would give you some help as to where to spend the money, maybe for the most interoperable endpoints.
Excellent. So Fallon, let's fire up question number 3 on the polls. And then also, Kristen, you want to read Charles's question, because I think this is one of the key issues that may prevent people from making the leap, if you will.
Yes, one moment while I pull that up. I apologize. Here we go. From Charles, I think the world of IP is not as simple as it sounds. In an SDI environment, other than redundancy, to breach an SDI system would require a physical presence. IP comes with a whole lot of challenges with security, with which most broadcast engineers are not typically conversant with. This is a whole new world of possibilities and danger as well.
Not a question, but a statement. But anybody, I mean, this is obviously one of those things where I think the higher ups would say we can't do this because of the risks or whatever. So, Robert, what's your sense on?
Yeah. So did you connect it to the internet? I mean, what kind of stuff are you throwing in your laptop here? Are you allowing people to connect to your virus-enabled laptop? Are you moving USBs around? It's the same thing as anything else. So, I mean, I regularly go down to the hack sites and all these places to download the latest viruses on my home laptop so I can share it around. So no, I'm just kidding, but it's only as secure as you want it to be. I mean, quite frankly, is if you started with security in mind, and security is not about a product, it's not about a practice, it's a way of doing things, right? In a lot of ways, we say, just like with your broadcast environment, did you connect your playout systems, which are probably already IP? Did you connect that out to the internet? Sometimes you got to get a license or something like that, but you pinhole it only to get to the license server. So you follow the same principles. I don't think there's anything different in that. With the IP, yes, you have more capability to connect things over to your IT system, but why would you want to do that? But what it does give you is the ability to think flexibly now. You can connect your post systems, your graphic systems, things together, which were islands, and connect that up, the rest of it. Now, did you get hacked with your playout system? Probably not. So it's the same principle. So I think security is already intrinsically there, and we're already just aware of it. I think the paranoia is a little bit, I hate to say this, a little overblown a bit because we're scared of it because we're, like I said, going to hack sites all the time. And why we're doing that, God only knows.
Anybody else thoughts? Is this an overblown, not overblown concern, but
no, it's not overblown. It's the wrong word, kind of, but it is of course something you should care about. And Robert's completely right. Either you have a security instinct kind of mentality, and remember, all the fancy SDI routers you have, well, they're under IP control, are they not? And that is the kind of question here. So you already have a huge IP control system which runs your TV station, your outside broadcast vehicle, your whatever operation. And if you get hacked on that one, well, you're just as doomed as if your 2110 network gets hacked. So it's not a big difference there. It's just about, if you have security consciousness, you're not going to be, damaged at any point. But of course, it's like any flexible technology. Don't let anybody in there. That shouldn't be there. It's like access passes on a sports venue. You don't really want the other guys in there.
So, Simen, it's an interesting point. Is I remember I was working on this old television station here, and they had a Windows 3.1 system running their control environment. And I looked at that, and everybody said, "Don't touch it," right? But in the new modern way of doing things is, patch and keep things up to date. And I think that's the new adopted way of most broadcast engineering organizations these days. Keep your stuff up to date, put your patches on there, and don't get stuck with the old stuff that you can't support it.
No.
So it's kind of got, like, I guess, 4 pointers. So a lot of the big 2110 centers that have been constructed recently, the handoff point to the networks is still SDI. So actually they're coming down to baseband. There's an SDI timing plane, which then hands out as well. So people are still using SDI as a firewall, if you like, in terms of breaking the LAN there. That's one approach people have taken. We talked about the VSF and the secure APIs that they're preparing for WAN connectivity. AMWA with NMOS are preparing for just finalizing their security model for AMWA APIs. That's ongoing, and part of the JTM testing as well at a product level. One of the things that happened was that we all went some pen testing undertook that. So there's on GitHub as well. There's a kit which tells you there's a list of how to install this on a Raspberry Pi and sit there, and it'll just download the dedicated version of Linux. They pull down the latest test suite from the web, and it'll sit there and just bash away at a particular product which is under test. And we all gave our results back for that. So that's not public, that information as to what ports are open and all the rest of it on our equipment. So it is being looked at by the industry. It's multi-layered. As you talked about before, if you just got one firewall and once you're in, the world's your oyster, that's a business decision that you take, but it's obviously not recommended as a way forward. So you need to think about this through in the same way that you'd address any other business decision that you're doing, and risk management. But there are a number of technical solutions out there which are they're non-proprietary and being done in the way that is people are promoting this across the industry. So.
Excellent. Well, here's the poll results. So again, I guess this is why we're doing the session.
That's right.
And that
Right down the middle, right down the middle.
Yeah. So we have another great question, Kristen, from Jet Lim. So you want to fire that one up as well?
Yes,
about replacement
sure thing.
cycles?
Okay, from Jet Lim, often I get obstacles to persuade into IP is the maintenance cost compared to the SDI environment. The cost of replacing switches every 4 to 6 years. What are real cases you recommend? The cycle of refreshing network infrastructure in case IP is adopted.
Well, that's got to be an Arista answer to this one.
Yeah. So, I mean, I'm sure Robert's got a view as well, but yeah, I mean, I know of plenty of installations that were built 5+ years ago running 2022-6, and they are still perfectly functional systems. The kind of refresh cycle in the data center, in the kind of, like in the cloud data centers, is pretty rapid, but that's because their expansion is incredible. So if you are going to be building a 2110 system today, I would definitely be thinking about how you wanted to expand it in the future, because I've not built a single 2110 system that stayed the size I built it. They've all got bigger. But if you talk to your vendors, that's the thing to do, right? Talk to your vendors, ask them what their life cycle models are. I can talk to you about, if you want to catch me offline, I can talk to you about ours, but we have switches which are, we've only just end of life to switch, which is 12 years old, right? So that doesn't happen for every single switch model, but our approach is that whilst customers are still buying the products, we still make the products, because there's no need for us not to do them. We have lots and lots of customers who continue to buy what appear to be outdated products, but that's because they like the product works, and they know all of its foibles. So it's definitely worth thinking about. I would be buying at the cutting edge of switching technology rather than at the trailing edge, because that gives you the more life cycle ahead of you. But honestly, like most DCs, I imagine most broadcast centers, the switching infrastructure cost is 10-15% of the cost of what are you building. So actually replacing that is another 10 or 15%, right? It's not enormous. I would pretty much guarantee that you're going to be up at 8K or 8K HDR or 8K some other magic new thing before you need to change your infrastructure too much.
Could I just have one small comment there, Gerard? And that is, our kind of experience is that every single high-end, real state-of-the-art switch and router that we actually purchased for digital systems, when we purchase more, we just delegate them to the edge, and it becomes, very, very fashionable, nice leaf switches. We the last kind of, I say about 8-9 years, we haven't thrown anything away. It's still in production, but it's not in production in the core. We replaced that with higher end models, but we delegated it to the leaf, and it's still there. So to be honest, I see a life cycle which is pretty long for these high-end switches. I wouldn't be concerned about that at all, because everything over 8 years for me, that's a pretty long life cycle.
I think that's a really good way of seeing it. And the other way of viewing this is back to the data center model. The bit that you really want to spend quite a lot of time thinking about is your fiber plant, because that is difficult to replace, right? That is including, you have to knock your walls down to replace that. So if you can think about that in advance, and remember that glass is just glass and light is just light. So it doesn't go quite as far when you make it go quicker, but it's nowhere near as bad as having to rip up your RJ40, your BNC cabling and replace it with something that can do 12 gig, not 3 gig, right? So yeah, less of a problem I think maybe people are perceiving as.
Yeah, you can use the same fiber for much higher data rates than you can with coax and SDI. You hit a limit. That's just physics.
Absolutely, yeah. And most Simon's point is really good, actually. If you're talking about stuff at the leaf layer, the edge, then those switches are, they're relatively small. They're not going to cost you huge amounts. If you're talking about the core switches, maybe you're building big monolith, big kind of chassis-based systems. Well, if you're careful and think about it up front, talk to your vendor. There's investment protection that you can build in there. You can buy chassis that will still be usable for the next generation of line cards, or you can replace the fabric modules and upgrade the line cards. So we try really hard not to force you into buying new stuff you don't need. Many vendors have a similar approach.
Yeah, what's interesting about that is, and not to get too off the rails here, is looking at a QSFP. You can have 100 gig, 40 gig, 4x10, 4x25. So it's about the fiber infrastructure. And actually, we strive to look at what are you connecting, basically the ground up. What are you trying to connect to? What are you trying to service? Because the network is there to service the endpoints. Ken, does that count by fourth saying there? Okay.
Yeah, there you go.
Never mind.
So as far as the God, time's running out already. Jeez.
I know,
So Kevin, we may go over a couple minutes. Is that okay? So I guess I want to kind of go to the part 3. We haven't gotten to part 3 yet. This is running with IP.
Running.
I guess. But we got some good audience questions in, which is always great. So as far as the lifting and shifting, let's call this. This is then basically, and we kind of discussed this primarily right to date on this call, which is you have an SDI workflow, you're going to lift it and shift it into IP, but you're not necessarily going to really kind of take full advantage, if you will, of the IP world to expand your possibilities of content creation and distribution. So blue skying it, where do you think we'll be? And, some people are already there right now, actually, obviously. But as far as how will IP change the way, when you look to go beyond lifting and shifting, what are some ways that you think are some ways that people can conceptualize what the possibilities they will open up? I mean, I'll give one, for example, is obviously multiple, commentary tracks with, 15 people doing the commentary as opposed to just 2 guys, and being able to dynamically allow people to switch that and create 15 more broadcasts. So what are some ideas that you guys are looking at that you think are really neat?
Yes, I mean, the as you say, the personalization, audio personalization piece, which comes with some of the more advanced audio codecs that are around, is something which has been talked about, but no one's actually deployed yet. For me, we touched on it again as distributed production. If you like, I think the next generation thinking, certainly here in the UK, is that people are trying to drive down the carbon footprint of live sports production, and also, it's a pretty stressful life being on the road all the while and continuous. So they're trying to improve the quality of the experience, everybody. So to minimize the travel, people are talking about having multiple access nodes to the equipment, which is local to where they live. And bear in mind, people who work in live production, they don't live in cities. They travel to venues all the while, so they tend to live out in the country, and they don't want to live in work in a central city broadcast plant. Is not really appropriate for them. But with the modern IP systems, you can do that. You can remote surface in from 4 or 5 nodes, or even from home if you can guarantee the link, and that does mean that say your replay machines and everything else, they can be placed centrally. People can dial into them, and they can be used in the morning for the 11:30 match, and they can be reused again for the 4:30 match, and so you're getting double the amount of effort out of those. And also you can then put the high capacity file transfer links into those devices. So I've done there. I've sat there for 4 hours and in Wembley pulling the files off the server, especially at 4K. It takes a long time to get them off there. So there are all that sort of stuff helps build in the flexibility, and I think we'll start to see quite exciting innovative solutions to this. So,
well, that's where this becomes, this kind of interesting technology, because again, you can kind of say that it's not an apt thing, but maybe IP is like a backplane. So basically everything you do, processing or storage or caching or whatever, basically IP has the capability of dissolving time, because with an IP network, you can do 2 things. You can do real time, but you can also do faster than real time.
Faster real time.
And that is the power to actually be able to do that over the exact same network, the exact same infrastructure. So if you then choose to be at home or somewhere else, basically, again, distributed kind of production, you can then do editing with mass amount of buffering and everything, and you can do real time as well. And the network is not a limitation. In the old days, well, that was a real-time cable. This was a non-real-time cable. Nope, now it's actually one cable, and you can do whatever time you want. That is the big dramatic change. Because again, you just move. Location doesn't matter, time doesn't matter. And that means that basically, if you want to say, oh, that rendering won't do on my laptop, well, send it to the render farm we have centrally. That's not a problem. So it's all about moving space and time.
That is so deep.
You need another audio, fire up another multicast, and you've got one more audio. I mean, same thing with video. It's on the same pipe, it's on the same switch.
Yeah.
The flexibility, the stuff we couldn't do on SDI. SDI was a single link, a single entity, and this allows for so much more flexibility and be able to move, instantaneously on react to change.
Adaptability. You just hit it, Steve, right in the head.
Exactly. Yeah.
I mean, some of this has been done now. So in audio world, being able to dial into a microphone preamp from 1,500 miles away, you don't need to send an A2 to site in order to tweak the knob on there. I mean, that makes a huge difference to the efficiency.
Yes.
Remote shading, particularly for onboard cameras,
yes.
and that's being done. That's almost routine for Fom and Donna and the people who do this. But where you've got 22 events all over the world. Okay, they have to get up at 3 a.m. if it's Australia, but they're still in Barcelona, right? People are already doing these kind of taking these approaches.
Well, you mentioned Barcelona, and that means, of course, that the sales guys for Pata Negra ham and Manchego cheese, they're going to have a hard time because nobody will come there.
Yeah.
Awesome. Well, obviously we're just beginning this conversation. If anybody wants to take it offline, there are contacts in the chat, so be sure to reach out to your favorite panelists to follow up with them, because I have lots more information to share, obviously. Kristen, thanks for hosting this, and thanks, guys, all of you, for taking part. So Kristen, I will give the final word to you, and thanks everybody for tuning in, obviously, as well. So Kristen, take it away.
Yeah, thank you to everyone who joined us today. If you want to contact any of the panelists, you'll see that in the chat. This will be made available. We'll have the video up shortly, and all of the contact info will be available with that if you don't catch it from the chat here today. We appreciate having you here, and we are hoping to make this a series, so we hope to see you again soon.
As mentioned during the session, if you have any questions, please don't hesitate to reach out to any of the panelists, and their contact details are currently displayed on the screen. If this seminar has whetted your appetite and you want to learn more about SMPTE ST2110 and live production, can I recommend the latest Leader white paper, which can be downloaded from the link currently displayed on the screen. So thank you once again for joining us, and if you have any questions, please don't hesitate to contact me on the numbers currently displayed on the screen.